These are notes 12.4, special segments inside of circles. I'm going to take a look at a couple terms first. The first one is a reminder when we have a secant, that's a line or a segment that intersects the circle in 2 points. A chord is a segment whose endpoints are on the circle. A secant creates a chord. So the terms secant and chord can be interchanged in each one of these descriptions. So you can see in our example here, segment AB is the chord created by secant, the secant line AB. Okay? So we're going to be concentrating on these segments today, the chord and as being part of that secant. Okay? So let me talk to you about some of the more terms. First one is segments of a chord. These are segments created when 2 chords intersect in the interior of a circle. And you can see here, I've highlighted those pink. Segment AE and EB are the segments of chord AB created when chord DC intersects it. Next term is a secant segment. That's a segment that contains a chord and has exactly one endpoint that is outside of our circle. And you'll see that this secant segment is FH. It's a secant because it goes through the circle, but one of the endpoints is outside of the circle. When I look at this secant segment, that secant segment has an external segment, and that's what's highlighted in orange. That's the portion of the secant segment that is outside of our circle, segment FG. And then the final segment that we want to look at is a tangent segment, and that's when you have a segment that's tangent to the circle. One of the endpoints is going to be on the circle, the other point is going to be outside. In this example, we have KF. Now, as we go through today's lesson, you're going to see we're dealing just with segments. There are no arcs. There are no angles. No arcs or angles in today's lesson. The pictures are going to look similar to what we've had the last 3 units, but not on this one. No arcs, no angles. So the first picture I want to show you occurs when 2 secants intersect inside of our circle. And I've used some color coding to help you see this, but I've got this secant AC intersecting this secant BD. You can see the parts AE and EC are in segment AC. And the nice thing about this is these links multiplied together will give us the exact same value as the other 2 segments links multiplied together. So let's take a look at a quick example over here. You'll see in this diagram the 2 secants intersect, creating a length of 5 and 12. If we multiply those together, they'll equal the lengths of the 2 parts of this chord, x times 6. A little bit of multiplying in algebra gives us x equals 10. 10 times 6 is the same as 5 times 12. That can even work when we look at a circle, and in the circle we have a bunch of expressions. You'll see in this one that the 4x and x are part of this chord, the x plus 1 and the 3x are part of the other one, resulting in an equation that looks like this. X plus 1 times 3x equals 4x times x. When we distribute the 3x, we get 3x squared plus 3x equals x times x, x squared times 4. What I can do algebraically is subtract 3x squared from both sides, subtract 3x from both sides. The result will be this equation here. To solve this, what you'll need to do is go to Desmos, and in Desmos, type this equation in exactly. What you're going to see is a graph that gives you the zeros. Remember, zeros are the values of x that will give us 0. One of them is x equals 0, and the other one is x equals 3. Well, in this case, if x equals 0, we don't have a circle, so the only solution here is x equals 3. This can also be done by factoring. Let's take a look at our next example. In the next example, we have two secants that don't intersect inside, they intersect outside. And as you recall, this looks just like the problems we had yesterday, but no longer are we looking at angles and arcs, we're looking at the lengths. The length outside of this segment, AB, times the total. This is the part that's on the outside times the total, is going to equal the part that's on the outside times the total of this other one. So in our example here, you'll see that 6 is the length of this secant that's outside. This distance here is 4, so the total length is 6 plus 4, or 10. Part times the total equals the part 5 times the total. Notice this expression for the total is not 5x. It's this length of 5 plus this length of x. That gives us this one here. Okay? So that's why we have x plus 5. That's the total length. 5 is outside, total length is here. And you'll see we do 6 times 10 and get 60. Distribute the 5. This will give us 5x plus 25. Subtract the 25. And then we solve this by dividing by 5, and we get x equals 6. In the next one, you'll see again we have some expressions to deal with. First of all, we have to note that 3 is on the outside. Since this length here is x plus 2 and we need the total, we need to add the 3 to the x plus 2 for a total of x plus 5. In the second secant, we have a length of x plus 1 here. That's the outside. The total is going to be that x plus 1 plus this x minus 1. When we add those together, this will be x plus x, 2x, and the 1 plus a negative 1 gives us 0. We're going to do our algebra by distributing. 3 times x, 3x, 3 times 5 is 15. X times 2x gives us 2x squared. 1 times x gives us 2x. When we subtract 3x and 15 from both sides, we'll be left with this equation. 2x squared minus x minus 15. Same thing again. Put this into Desmos. That's going to graph it. You're looking for the zeros. One of the zeros is negative 2.50. The other one is at 3, 0. A negative value for x will not work in here, so the only value that will work is when x equals 3. That is the solution to this problem. Let's take a look at our next picture. In our next picture, we have, just like we had the other day, a tangent and a secant. This time, we have a part of the secant that's outside, WZ, times the total, WY, equals, on the tangent, the part that's outside is the same as the total. So you'll see that this is a WX times WX, because that's both outside and our total length. We've got a quick example over here to show you. And in this circle, you'll see that the secant has 6 on the outside. The total length will be this 6 plus the 4 that's on the inside for a total of 10. The tangent line is x long and x long for the amount that's outside. Therefore, this is going to be an x times x. X times x is x squared. 6 times 10 is 60. Therefore, our answer will be x equals the square root of 60. And we can leave it like that if it's an exact value. If we're asked to truncate to 3 decimals, then we put it in our calculator and stop after 3 decimals. Okay. Let's take a look at our next example. In our next example, you'll see that again we have a secant and a tangent. The part of the secant that's on the outside is highlighted in green, 2x. The total length will be the 10 that's on the inside plus this 2x that's on the outside for a total of 2x plus 10. On the tangent portion, 3x is on the outside and 3x is the total. So this will be a 3x times 3x, or 3x quantity squared. I want to point out to you that these two are not the same thing. When we square this 3x, the total, then we get 9x squared, as opposed to just 3 times x squared. Let's do the algebra of subtracting 4x from both sides, or 4x squared, and 20x from both sides. 9x squared minus 4x leaves us with 5x squared minus 20x. Again, put this into Desmos. When that goes into Desmos, it's going to have an intersection here at x equals 0 and an intersection here at x equals 4. X equals 0 is not a solution we want. X equals 4 is the correct one. Let's go ahead and look at some examples. Okay. So let's start off here with the very first one. And in this, you'll see that we have a 3 and an x for this secant, and a 4 and a 9 for the other parts of that one. So you can see 3 times x equals 4 times 9, 3x equals 36, x equals 12. The next one, similarly, we have 9, excuse me, not 9, but 11 times 2, those two values, and then we have 4 times x. 4x equals 22. Divide both sides by 4. We get 5.5. Next one. This is a case where we have a part that's on the outside. The 3 times the total. The total is 8 because it's 5 plus 3. That's where this 8 comes from. On the second secant, the part that's outside is 4. The total is going to be x plus 4. That's the total of that. Algebra, make sure that you distribute the 4. 4x plus 16 equals 24. Subtract 16, divide by 4, and we get x equals 2. Let's look at our next one. In the next one, you'll see that the part that's outside is the 10. The whole thing is going to be the x plus 10. And on the tangent side, the 20 is both the outside and the total length. 20 times 20 is 400. When we distribute the 10, we'll get 10x plus 100. Subtract 100, divide by 10, and we'll get x equals 30. Next one, you'll see that we have a length that's on the outside. That is 6 times the total. The total is going to be the 6 plus 2 for a total of 8. On the other side, the part that is on the outside is the 3x. The total is going to be the 3x plus the x that's on the inside for a total of 4x. 3x times 4x is 12x squared. 6 times 8 is 48. Divide by 12, we get x squared equals 4. And then, when we square root that, we get x equals 2. Okay. So, you'll see that there are a few more here that I won't go through each one totally, but inside, part times part, x times x, 1 times 8. 1 times 8 is 8, x times x is x squared, x equals the square root of 8. We can even have decimals. You'll see on this one, we have a part on the outside times the total, 0.8 times 1.8. Outside and the total are both x, which means this is x times x, x squared. When we square root it, we get x equals 1.2. Okay. Next one, you'll see that 5 is the portion that's on the outside. The total is going to be x plus 5. On the other side, the part that's on the outside is x, and the total is going to be an x plus 5. Distributing from both sides, we get 5x plus 25 equals x squared plus 5x. Subtract the 5x from both sides, we get 25 equals x squared, square root, and we get 5. Okay. You can see I have set up these others. You can take a look at these, pause the video if you want to look closer at each one of these to check your work. But that concludes our notes for today. Make sure that you use these and keep these handy while you're doing your homework. And good luck to you the rest of the day.